Today's lesson is on finding area. We're starting on page number 9 in your notes packet. And we're going to start off with just a basic definition of area. Area of a figure is the number of square units a figure encompasses. When we first started talking about area, you probably started in elementary school, and you probably started off with a piece of grid paper that kind of looked like this. And you might have had a rectangle or some other pretty basic shape drawn on there on the grid. And then you counted up and said 1, 2, 3, 4, 5, 6. And you said that this had an area of 6 square units. So that's where we actually get the definition of area. So whatever our units are, if these were inches, we would have inches by inches. There are actually 6 of these 1 inch by 1 square inch blocks that this is actually taking up. So that's how we're getting the square idea of things. If you remember, if we were to actually just draw a line here, we could say this line is 3 units long. This is what we call a linear measurement because it's like in the shape of a line. Linear measurements are when we see measurements along the sides of different shapes, but as soon as we start talking about square, we're talking about actually coloring them in. And that's what I kind of liken this to, is if you're actually coloring in, how many of those little squares are you going to be coloring as you go through to find the area? Our steps that we're going to follow is to item number 1, identify the shape, and then we're going to be using our formula sheet that you were given at the start of this chapter. The steps that Mrs. Grabner is requiring you to do is to locate and write the formula. You will have to write the formula with nothing else filled in to show me that you know what shape that we're talking about. Once you've figured the formula out, you identify the key parts that are needed for your formula, plug in your values, and calculate. So what we're looking for here is basically a 3-line process, and I'll demonstrate that for you in the next couple examples. In this first one, our name of our shape is actually a square. So when we go to our area formula sheet, we look for the picture of the square, and we notice the capital A. A represents area, and you see the formula A equals S squared. That comes straight off of your formula sheet, so you need to have that out next to you so that you can actually look at it. This is the first step in our process to identify the formula. S represents the side, and if you look in our picture, it tells us the side is 7. So our next step is to go ahead and plug in. A equals 7 squared. Our final step is to go ahead and actually calculate. 7 squared really means 7 times 7, which gives us 49. We also need to include units here. Because we're talking about square units, we write that out as feet, and then we put a little exponent 2 on it. This is the more preferred method. You are also welcome, if you're typing this out on ClassKick, if you're virtual that day or whatever, you can actually write out square feet as well, but this is going to be the preferred method when you're writing things down, and that's the way that you'll see it on paperwork for other things. Go ahead, take a look at this shape that we have here. Take a look at your formula sheet and answer the question to identify what shape we're working with. If you pick rectangle, you're on the right track. And looking at the rectangle then, your area formula is A equals LW. Because there's no symbol in between there, we know that it's multiplication. So now we look for the L on the picture, which goes across the bottom. It's 10. And we look for the W, which is 8. One thing to also note is always check your units to make sure that they match each other. If not, you may have to actually convert units. 10 times 8 is 80, and we're talking about centimeters and its area, so we're squared. Or you could write out square centimeters. In this next example here, we have a triangle, and what I would ask you to do is to actually probably take your notes packet and turn it upside down so that you're looking at this triangle here. Inside every triangle, you are going to have to find the height of the triangle, and the easiest way to do that is to find this little right angle symbol. The height of a triangle is always going to be perpendicular to the base, so you may want to make that note. Height, always perpendicular, and I'm just going to shorten that, to base. And keep in mind, perpendicular means that it's at a 90-degree angle. The other way that I'd show you how to do this is if you kind of turn this into a lowercase h, this is your height right here. And then the base of the triangle, if you close out the h, you end up with the b. So the 20 here is your base. So looking at the formula sheet, we have our triangle, and our formula says A equals 1/2 b h. Notice the difference between upper and lowercase letters. In our triangle here, we figured out that the base was 20 and the height was 12. That 15 off to the side is just extra information. Go ahead and multiply 1/2 times 20 times 12, and you get 120. There's no symbols on here, so we're just going to call this units squared. So those are our first 3 examples for area. Taking a look down at the bottom of page 9, we have 3 more examples here. In my first one, I have a parallelogram. And looking at the formula, my formula is A equals BH. So I need a base and I need a height. Take a look at the picture. That's your height, and then you'll be able to figure out your base. So my first question to you is, what actually is the measurement for the height of this parallelogram? Height of the parallelogram is 10 inches. Next question, what is the base of this parallelogram? Base of the parallelogram down here, close up the H, and you have a B. Your base is 22. So to find your area, you're doing 22 times 10, and then multiply 220 inches squared. These are the 3 lines that I'm expecting to see when you do these types of problems. Next example here, we have a rectangle. And we have in here A equals LW. Notice there's no L and W on the picture, but what we can do is take a look across here, length and width. So area equals 10 times 4. 10 times 4 is 40, and it looks like these are centimeters squared. Last example that we have here is a trapezoid. And when you get over to the trapezoid formula, be super careful as you write this one down. It's a long one. A equals 1/2 H, parentheses, B1 plus B2. So when you look at the trapezoid, the bases that are here are going to be your parallel sides. Remember, a trapezoid has one set of parallel sides. So that's where your bases are. So these are B1 and B2, and they're interchangeable. You can say this is B1 and this one down here is B2 because you're just adding them. So it's not going to make a difference. In here, we have our H, we have our height. So we can go ahead and start to plug stuff in. 1/2 times 4.4, parentheses, and I'm going to do 9.3 plus 6.7. Again, doesn't really matter if you swapped them out. So here, what I need you to be very, very careful of is we need to follow Pemdas. And Pemdas tells me that if I have anything in parentheses, I need to do them first. So we can actually add an additional line in here if we so choose, or you're welcome to type this into your calculator at one time. Regardless of what you do, please be very, very careful because this is a plus inside here. And a lot of times people will get on a roll and they'll do 1/2 times 4.4 times 9.3 times 6.7, not realizing that this is a plus and not realizing it's in parentheses. You can type in your calculator 1/2 times 4.4 parentheses 9.3 plus 6.7 parentheses. Try it right now and verify that you get 35.2 because that is actually the correct answer. Your units here are inches squared. So again, my question to you right now is, what do I have to watch in particular about this formula when I'm actually typing this into my calculator? There's a part where a lot of people tend to mess up. If you said we were talking about the plus sign in here when we add the 2 bases together, you are absolutely correct. This ends the lesson for today. You do have some practice things to do, and we'll be doing some more examples with some of the basic area.